Alright, third video of 3. This one is the 6th period video. We'll start at 21 and do every third problem. Okay, limits. First go is always plug it in and hope that it works. It usually doesn't. 0 over 0. So here we go. Right off the bat, we got to use one of our algebra techniques. Although this one doesn't look bad. Factor out a 2x from the top and a 3x from the bottom. And so the x's will cancel. And then we try again. So you do your algebra trick, hopefully something cancels, and then you give it another go, and hopefully what canceled was good, and when you plug things in, it will work. So 2 over 1 is 2. And 33. We had some numbering issues here. So if we went from 21 to 31, so if we skip 2, somehow we land at 33. Plug in 0. We get 7 over 0. Okay, 7 over 0 means... not algebra trick. 7 over 0 means I need to figure out if this is infinity or negative infinity. Okay, well the top is definitely 7. The bottom, because it's squared, is always going to be positive. So this answer will be infinity. It doesn't matter which side I plug in on 0. When I square it, it becomes positive. So 7 divided by a really small positive number is infinity. Positive. Let's see. Limit as x approaches 2 from the right of h over g. You might remember me saying that the biggest issue with this is please make sure you look at the correct picture. I mean, maybe that seems dumb, but that's kind of the heart of the mistakes on these. So limit as x approaches 2 from the right on the graph of h. So look at the graph of h. X approaches 2 from the right or the left, doesn't matter, that's 0. Limit as x approaches 2 from the right on g, that's 3. 0 divided by 3 is 0. Okay, same kind of thing here. Be careful about who's where. Yeah, we switched the order here. So we're still going x approaches 2, but now we've got 4 times the g limit as x approaches 2 is 3. And then the h limit as x approaches 2 is 0. So I've got 12 divided by 0. I need to be careful about, so it's d and e, but is it positive infinity or negative infinity? Why do you say positive? I agree with you.
Because it's going back up off the graph.
Okay. When we look at h of x at 2, as we get closer and closer, we're headed to 0, but we're always a little more than 0. We're always a little more than 0. So 12 divided by a little more than 0 would be a positive infinity. So it's that little more than, little less than stuff that throws people off. You good over there? No, you're not good, or yes, you are good. Ty, you all right?
I'm fine. I was just helping him out.
All right, 42. Actually, before we do 42, let me just recap here. If we get 0 over 0, or infinity over infinity, then there's where we have our algebra tricks. We can factor, we did that already. We can mess with fractions, that's what we're about to do. Or we can deal with conjugates. We'll see some of those as well. So those are our 3 algebra tricks we have to keep in mind. The good news is it's always pretty easy to know which one to use, because like 42, that's fractions and fractions. Let's make sure it's 0 over 0 before we try to fix anything. 1/3 minus 1/3 over 3 minus 3. Yeah, that's 0 over 0. So let's multiply by 3 and x. That will cancel out the 3 and cancel out the x. So in the first term, the 3's cancel. In the second term, the x's cancel. And now the x minus 3's will cancel. That's what we hope to happen. That's what we expect to happen. And now we get to try again. Limit as x approaches 3 would be 1/9. There's our fraction example. Okay, this next page, we have to work our way down the left-hand column. If I plug in 2, I get 2 minus 2 over 2 minus 2. So yeah, that's 0 over 0, which doesn't really work. So this is a conjugate problem because of the square root stuff in there. And then you multiply the conjugate side out, because that's the point of the conjugate, is to get stuff to go away. And you leave the other side alone, hoping that things will cancel. So in the top, root x plus 2 times root x plus 2 is x plus 2. The O and the I of FOIL I'm not going to write out because it cancels out every time. That's the point of a conjugate. And then negative 2 times positive 2 would be minus 4. And then in the bottom, we don't factor, or we don't multiply stuff out. We leave it as is in hopes that things will cancel. And they do. X minus 2 over x minus 2. And so now we get to try again with our substitution. So 1 over root 4 plus 2. 1 over 2 plus 2 is 1 over 4. So now we've seen one of each. Factor and reduce, fraction and reduce, conjugate and reduce. (48). So here's the multiple choice set of questions. Limit as x approaches 2 from the left. Okay, first job, always substitute, see what happens. 2 minus 2 over 2 minus 5. That's 0 over negative 3. So I'm not worried about which side it's on because it's 0. There is no positive or negative. So that's just 0. As a comparison, we're not really going to officially do, well, we'll do 49, but look at what happens if you switch the numerator and denominator. Now we get negative 3 over 0, which is one of the infinities, but I got to figure out which one by being a little more careful about what I plug in. So 2 minus 5 I'm not worried about. It's the 0 that I'm worried about. 2 minus 2 from the left. So 2 minus 2 from the left. So a little less than 2 is like 1.9. So we're headed to 0, but it's going to be a positive 0. Or a positive number close to 0. So negative 3 divided by positive 0 would be negative infinity. (51). Let's see, as x approaches infinity, that makes me think about the big terms. The only terms that matter are the biggest ones. So let's reduce this down to 3x to the fifth over negative 12x cubed. So let's see, that would be x squared over negative 4. So if I plug in infinity, the top's going to get really, really big and positive. The bottom is negative 4, so I'm headed toward negative infinity then. I'm hoping it's I think it's just going to be a plug it in and see what we get. Tangent pi over 3 minus sine pi over 3 over cosine pi over 3. Yeah, none of those are, this is not going to be 0 over 0. There's no conjugates or anything. This is just unit circle and algebra. Tangent pi over 3, that's root 3. Sine of pi over 3 is root 3 over 2. Cosine of pi over 3 is 1/2. So let's multiply everybody by 2. So I've got 2 root 3 minus root 3 all over 1. Well, 2 root 3's minus a root 3 is just root 3. So that one, there wasn't really any calculus in that. That was all unit circle algebra stuff. Alright, 57. For what values does x have a discontinuity? Okay, well I'm going to factor the bottom. And really that's all I'm going to factor. Because it doesn't ask me what types of discontinuity, so I can just tell already that it's discontinuous at x equals negative 3 and x equals 3. If it wanted more information, then I would need to factor the top and learn about who canceled and who didn't cancel, and so I'd know who was a whole and who was a vertical asymptote. But the way the question was worded just has a discontinuity. The only thing that matters is the denominator. Again, now that I've factored it, the negative 3 would be a whole and the positive 3 would be a vertical asymptote, but that is not what was asked in the question. Alright, it's number 60. I think I promised you one of these. Let me make good on my promise here. What value of k makes f continuous? So that means at 1/4, these two things need to be equal to each other. So this is going to be fraction yuck again. K times 1/64 minus k times a fourth minus a fourth. So that's sort of the left-hand side when x is less than 1/4. When x is greater than 1/4, 16 times a fourth minus 2. Four minus 2 is 2. And I think probably the easiest way to go here, I don't really want common denominators. I think I just want to multiply both sides by 64. So k minus 16k minus 16 equals 2. So negative 15k equals 18. Uh-oh, what am I doing wrong? Oh, 64 times 2. It's 128. How about that for fancy work? 128 plus 16 is 144. So k is 144 over negative 15. Uh-oh, is it not there?
Yeah, so I think you squared the 1/4.
Did I do something wrong?
Next square.
On this side. Oh yeah, you're right. 16x squared. So that should have been 1/4 squared would be 1/16. So 1 minus 2 is -1. Times 64 is -64. Plus 16 is -48. It's okay, it's 48 over 15. But that reduces to 16 over 3. No, 16 over 5. Ugh. That's for calculus, but it works for pre-cal too, right? Pre-cal is easy, algebra is hard. $63. Last one. Prove. Okay, here's one you probably want to see because I don't know that we've proved yet. This is not like geometry proof with the table and the statement and the reason and the given and the theorems and all that stuff. To prove continuity, just think back to the definition of continuity. The limit from the left equals the limit from the right equals the function value. So if we can plug into those and they're all equal, then it is continuous. If something breaks down somewhere, it's not continuous. So let's see. Limit as x approaches 0 from the left. That would be on this branch, because that's where x is less than 0. So let's plug in 0 there. Oh, it's not going to work because we get 0 over 0. So let's factor out an x. X plus 4 over 2x times 2x plus 1. So now if we plug in 0, we get 4. Because the x is, nope, we don't. I'm trying to do too much here. We get 4 in the top. And we get 2 in the bottom. So we get 2. So the limit from the left is 2. The limit from the right, so x is a little more than 0. That would have to be that branch. Limit as x approaches 0 from the right. That would just be 2. 0 plus 0 plus 2. Right, and then lastly, f of 0. Well, at 0, the equal sign is right here, so we would use this branch. 0 plus 0 plus 2. So we got 2 equals 2 equals 2. Therefore, f is continuous at x equals 0. So the prove problem, start with the definition, plug things in. If it all works, then you proved it continuous. If something breaks down, like will happen in 64, then you prove that it's not continuous.